Ahead and do our notes. So we're talking about simple probability and complements. So when we look here, our essential question for our first lesson in probability is, what is the probability simple events and complements? What can they be determined or represented? So when we see here, probability is the likelihood. Yes, it's the, let me zoom out some because maybe that's why. The likelihood of an event happening, expressed as a number between 0 and 1. I have no idea why it's doing that. All right, so probability can be written as a fraction, decimal, or percent. So when we look at the probability of something happening, our voices need to be off. We're taking notes. When we look at the probability of something happening, if it's a 0 chance that it will happen, we would count that as impossible. And if it's an impossible, because that means it's a 0 chance. Now, if it's in between, and that means that maybe it's like a 25% chance or 0.25% chance, or again, that's a decimal. If we wrote it as a fraction, it'd be a fourth of a chance. And what would that be as a percent? Exactly. 25% of a chance happening. That means that it's kind of unlikely. So if it's half as a decimal, 1/2 is what? Right. So 0.50. And as a percent, that means we just took the decimal over twice. That's 50% of a chance. That means that it's equally likely. And so when we go even further, because again, remember, we said that the probability is between 0 and 1, that when we get here, what level is here? 75%. So 75% of a chance. As a decimal, that's 0.75. And as a fraction, that's what? 3/4. So, and this one then, it means that it's likely to happen. And if we're at 1, we know then that's also 100%, which means that it's certain to happen. So this is the language of probability. We can have impossible, unlikely, equally likely, likely, and certain. A simple event is when only one event is happening. The probability of a simple event is called simple probability. It is the ratio of favorable which is also the part outcomes to the total, which is also, we call it the whole number of outcomes. That's why when we talked about the dice and we said, what was the chance of getting a 5 out of the 6 sides? You said it was 1 out of 6. Why? Because 1 is the part which is favorable, and the total or the whole was 6. So when we think of the complement, remember we said the complement is when something will not be possible or not happen. The complement and probability of an event is the not occurring. The simple probability and the complement have a sum of 1. So we're going to talk about what does that look like. So over here, here's an example for us. It says determine the simple probability and complement probability of rolling a 3 or a 4 on a die. So if I have probability of a 3 or 4, because that's how we will write probability. So remember, we know that's part over whole. So to get a 3 or a 4 as a part, what would that be out of what? So it's out of 6.
2/6.
So it's 2 out of 6 because that's only talking about 2 sides of the dice. It's talking about the side of the 3 and the side of the 4. And for those that still can't fathom that, on the side, I want us to write out all the numbers that's on the dice. So 1, 2, 3, 4, 5, 6. And we were trying to get a 3 or a 4. So a 3 or a 4, that's 2 out of the 6 numbers. So this can be simplified. What does this simplify to? 1/3. So when we talk about the complement, we're talking about the chance that something doesn't happen. So we use the apostrophe of not getting a 3 or a 4. So when I look back over at our numbers, that means I want to get either 1, 2, 5, or 6. So what is the fraction for that? Yes.
4/6.
4 out of 6. Do we understand that? Does that make sense?
Yes.
And this can be simplified to what? 2/3. And so what it's saying here, that anytime I know the actual probability and the complement, I should be able to add them up to get 1. So when I have 1/3 plus 2/3, that equals 3/3, which is 1. All right, so let's move to some practice. Because would it be tomorrow? Tomorrow's Friday. So next week we'll start where you guys will have more experimental opportunities to practice with dice, practice with things. So here we go. What is the probability of rolling a 4 on a dice? So what is the probability, Deontay, of rolling a 4? So if I have probability of a 4, what would that look like on a dice? So we can write out all our numbers on a dice. 1, 2, 3, 4, 5, 6. What's the chance of getting a 4 on the dice, Deontay?
Like the first, right? Oh. It's 1 out of 6.
So it's a chance of a 1 out of 6 because a 4, it only appears once. That's 1 out of 6 and it's already simplified. Let's go to the next one. Caroline, what is the probability of rolling an even number on a die? So 1, 2, 3, 4, 5, 6. What numbers are your even numbers? 2, 4, and 6. So what is the probability of us rolling an even number on the die, Caroline? 3, 6. Can this be simplified? And what does that simplify to? 1/2. Awesome. All right. Alan, what is the probability of rolling a number other than 1 or 2 on a die? So this is a complement. So we use that apostrophe. So 1 or 2. So we have our dice 1, 2, 3, 4, 5, 6.
4, 6.
So 4 out of 6 because we want everything but the 1 or the 2. So that leaves us with 4 out of 6. And what does that simplify to? 2/3. Thank you, sir. All right, we're at Hector. So Hector, this one it's getting a little more complicated. It says Daisy spins the spinner. So we have a spinner here with A, B, C, D. It says, what is the probability that she will land on A? So the probability of getting to A will be what? 1 out of 4. Great job. All right. Malaysia, what is the probability that she lands on a letter other than B or C? 2 out of 4. What does that simplify to? 1/2. Great job. All right. Let's see here. 4, 5. Okay, this is number 5. So no, sweetie, we are at Sophia. Sophia, so the table shows the number of animals in the most visited exhibit at the zoo. An animal is randomly selected to be fed in front of an audience. So on A, what is the probability it will be a flamingo? So let's look at the flamingo. Here is 12. But what are we missing? What do I need to know to find the probability of a flamingo? I'm going to just say F.
12.
Well, so is this a part or is this our whole?
That's the part.
That's our part. So all of these numbers here are parts. How do I find the whole, Sophia? How can I find the whole of all of these? Add them together. Can you go ahead and add them up for us? So we need a total because that is our whole. What do you get, hon? 30. So our total is 30. So now, Sophia, what is our chance of getting a flamingo? What would that fraction look like? So here's our flamingo. What would that fraction look like? Remember, we have to put the part over the whole. So what would our part be?
12.
Thank you, sweetheart. But this is Sophia's question. So Sophia, you heard the answer. So now I want you to look at the table. What is the answer now? What's our part for the flamingo? What's our chance for picking a flamingo? What's the number? Sophia. If I look at the table, what's the number that's next to flamingo? 12. So that goes at the top, 12. And what's our whole? What did you just tell us? What was our total? 30. So now we know it's 12 over 30. But this can be simplified because they're even numbers. So Sophia, you're almost there. Let's go ahead and just divide these by 2. What's 12 divided by 2, sweetheart? 6. And what's 30 divided by 2? 15. So our chance of getting a flamingo will be 6 out of 15. You get it? Awesome. All right, let's go to the next. So Nina, what is the probability that the animal selected will not be an elephant? So I don't want an elephant, so I don't want this one. So what do I need to do to find when I don't want an elephant? So we know that's a not situation. So remember, we want to deal with our part over our whole. So Nina, the first thing I need to know is how many are here that's not an elephant. So how much? So we know our total is 30, right? Can I just subtract the elephants? So what is 30 minus 2? So 28. And then what is our whole? Or our total? We wrote it up here. 30. This can be simplified because they're even. What does this simplify to? Because that means we're dividing it by 2. Again, this is her question. We're going to divide by 2. Thank you. All right. So Nina, what's 28 divided by 2? I thought I heard 14, but did I hear 14? Okay. 14. And then 30 divided by 2 is what? 15. So 14 15s. Yes. True or false? So now we're moving over to Mackenzie. Mackenzie, true or false? A flamingo is twice as likely to be picked as a crocodile. So if we look at the crocodile and we look at the flamingo, would you say that a flamingo was twice as much as a crocodile? Can you tell us why you say it's true? Right. Okay. So because you said because half of 12 is 6. I love it. Great job. All right. Let's go to the next person. We're going to get to you. We got a whole nother page. You're good. So the table shows the different book genres Ray has on his bookshelf. He will randomly, voices off, pick a book to read. Determine if the statements are true or false. I would like for you to go ahead and answer these for yourself and then thumbs up and let me know when you're ready to share. Oh, yeah. Yep. When you have an answer, you can raise your hand. So Ray is twice as likely to pick a mystery book versus a sci-fi book.
Yes.
Who has an answer for that? Alan? Okay, Alan, tell us. Is that true or false? So Ray is twice as likely to pick a mystery book than a sci-fi, and you're saying it because it's doubled, right? Okay, true. Okay, so do you have the last one? Alexis got this one. Ray is 3 times as likely to pick a fiction book versus a mystery. So is he 3 times as likely to pick fiction over mystery? Again, this is Alexis' question. So you're saying that fiction is 3 times mystery? How many times is it?
Yes.
I'm asking you. No, listen. I want you to get this because you wanted to answer a question. So if mystery is 12, right? And they tell me it's 3 times, that fiction is 3 times that. So what's 12 times 3? 36. So is fiction 36?
Yes. No.
It's not. So is this true or false? False. Good job. All right. So these are our notes. You got to think about it. It's the language. That's why probability is a language game. But good job. Someone has to go before you, so you can go right after. It was Alan. No, sir, you didn't. So please go ahead and get started on the practice page. Oh, thank you. Please get started on your practice. Oh, you're always welcome.